And here we are. I know there's so many people have been asking me about this. The Browning Mark IV with the Nightmare PLL module. I'd had the brainstorm of installing a VFO in it. So we're going to be tackling that now. So I've already gutted the transmitter. So if we flip it up here, you can see there's a huge hole here, and all of the circuit boards that would go here are gone. So let me pause the video and I'll show you what I'm removing, or what not removing, what I have already removed. And here it is, in its nightmarish. God, I hate these things. These were just such a, oh my God, so poorly designed. It's almost funny. Like I say, this one had some channel modification done to it, and it's just, traces are cut up under here. There's, like I say, address lines, these lines here, some of these have been rerouted. There's parts bodged on the board all over the place. You know, it's, man, I mean, and no matter what you do to them modification-wise, you're still left with the exact same module. It may do a little bit more, but you're still left with the same piece of junk. It's just so prone to fail. Another problem was, when they did this, these holes are not supposed to be here. Yeah, you see how that now looks like a block of Swiss cheese? It's not supposed to look like a block of Swiss cheese. It's supposed to be solid metal. It's an RF shield. Well, it's not shielding a lot if it has all of these holes in it. So the removal's not really that hard. It's basically just, you're gutting it, quite literally. If there's a wire and it goes to this thing, cut it off, because this is completely going away, all three boards. We will no longer be needing any of this. We will no longer be needing the rotary encoder, or the spring-loaded rotary encoder that they use. Is just a spring-loaded wafer switch, so it's not exactly a rotary encoder. And then the other two switches on the radio, the scan rate and the test reset switch, they will, you know, they're still in there. There's just no wires hooked up to them anymore. They're not going to do anything anymore because they're completely not needed. I mean, and that's a good thing to tell people. It's easy to tell how poorly this works that they had to put a reset switch on the front of the transmitter. This thing locked up so frequently that you would have to reset it. So, like I say, all of this is going away and is being replaced with this. Okay? Now, you have seen this before, but you may be thinking, well, that looks a little bit different than it did before. Well, it does look a little bit different. I've added a fourth board to it. Now, this module, the way I got it, has a display board, has this maker's, the actual microprocessor board, the controller down here, and then this is the actual VFO, or the actual DDS. This is the signal generator right here, is the crystal. This does not have enough output. Even with this little jumper in the high position, it does not have enough output to drive the Mark IV. So what we have here is a Nomad amplifier buffer board. So that's exactly what it is. The name pretty much says it all. So this amplifier buffer board, I figured, well, no need to make lead links any longer, you go through anything complicated trying to find somewhere to mount this damn board. I'll just mount it to the rest of the everything that's being installed. So it's literally one module. There'll be very few wires. Literally the only thing that's going to this thing is going to be power and ground wires, and that's pretty much it. And then of course the coax cable will come off of this amplifier buffer board. Right here, here's the out, and then these two holes are, I can use either of those for the ground on the shield. But, you know, this is it. What you're looking at is what's going to replace all of that. So, now all I need to do is pop the faceplate off of the radio so I can enlarge the hole. Now, the only problem I'm going to run into, and it's not so much a problem, it's more of a cosmetics thing, the only LCD, 2x16 LCD display bezels, covers, shields, whatever you want to call them, because we have to enlarge this hole, okay? So we need to make it bigger. Now actually the height is just fine. I just need to enlarge it out basically to the outside edges of these two existing LED holes that are on here. The rotary encoder that's on that module will just go in this hole right here. And then these two controls down here will no longer serve a purpose other than they're filling the holes in the radio. But so I have to cut this out. Now we don't want to make this look like absolute shit, a rough edged metal hole with, you know, just looks like junk. So now they make small snap-in bezels, but they had such a narrow edge to them. I mean, very, very little. I mean, if you cut the display hole here out to this far, they only cover out about maybe this far. I mean, just barely enough, man. They just barely catch the edges of the screw holes on those boards. So I did find somebody that makes these. Okay, they make these little stick-on. You can see, it's got 3M on there, adhesive on the back. Now this is actually a multi-layer. So there's actually a clear window, and if it looks kind of scratched up, there's actually a protective film on the actual, you can see it peeling back there. So it's nice and shiny, okay? But, so there's actually a clear window here. That's not just a straight through hole. So it's a layer of this black material, and then there's a layer of clear on top of it. And it's die cut. But the problem even with this, now this is bigger than all the bezels, the actual plastic bezels that I could find. But even this, as you can see, when I put this on here, is not going to cover, get the camera down here a little bit, I can see it a little bit better, is not going to cover the low and high limit lettering on here. That's the only drawback of this. And I contacted the company I got these from and asked them, I said, do you make these yourself? If so, could you make them differently, or do you just buy them and resell them? And I have to give them a big thumbs up. They're actually an eBay seller. That's where I got these. But I have to give them a big thumbs up that they were completely honest with me and gave me some information. And they said, no, we do not make these. They actually gave me the company that makes them. I don't have that right off the top of my head. I did bookmark it, but he told me the company that makes them. And he said the only drawback about getting these things is it is ungodly expensive to get the initial setup fee to get these things made, because they're actually die cut. So there's tooling involved. It's not just a standard, they just basically, print it out and laminate it. This inner hole and this outer diameter are die cut. So that means there's going to be a tooling or setup fee to make these things. And I'm very familiar with tooling and the prices of how much it costs for, initial setups on stuff. So I might contact that company and see if, tell them, hey, I've got some of the windows or the, your product. I just need it to be a little bit longer, and see if maybe there's some way without a manufacturing change in tooling, because I don't know if they're using two different dies. Are they using a single die and punching out the inner and outer diameters at the same time, or do they have an inner die to punch this out and then a separate one to cut the outside? If they have a separate one to cut the outside, hell, I even wouldn't be that bad. See, they're nice rounded over corners there. They're not a sharp 90-degree point. Even if they could just cut them out square, something just to make them a little bit longer. So, for now, this one's going to go on here. And since it's adhesive, it would be easy to remove at a later date. But what I'll do is I'll install this. I'm going to contact that manufacturer, go through everything, trying to get a wider one. If I can get a wider one without having to spend thousands of dollars in a tooling setup to get these things made bigger, then I can just pop one of these things in the mail and send it to this customer at a later date, and he can just get in there with his fingernail, peel the old one off, and stick the new one on there. But like I say, it really should be this wide. Either that, or I need to figure out a way. I'm not sure. I almost have to get out a blasted microscope and check this. That almost feels like it might be on top. I'm not sure. When this was silk screened, so you're gonna. I'm not sure if this brown, it was tan, the brown went on, and then on top of that, a layer of this tan again for the lettering and, whatnot. Or was the tan, is this tan printed on top of this brown, or is that just the brown had, basically the holes punched out? So that tan I'm seeing there is actually the base here, and then the brown was applied over top. And there's no additional printing here. If this is on top, maybe if there's some way I could get that off. Yes, I can't even feel an edge there with my fingernail. But that's the only thing. Mounting should be fairly straightforward. Like I said, I need to cut the hole out, 4 mounting holes, and then basically stick it in there, wire up the voltage, the power supplies to it. I'm going to be sticking some regulators in this thing to, but otherwise I need to, let's see, I got to take care of applying voltage. I need to supply a voltage to the relay because that went away. The original PLL module in this thing has a out-of-lock detector, which is actually 3 sections. It's an IC with 3 sections, and it blanks the display, which of course is no longer in the radio. And then what it would do is, actually it doesn't do anything. If the PLL's in lock, it doesn't do anything, which allows the voltage to be supplied to this. There's a pair of transistors that actually are hooked up to this. But if the original PLL that was in this went out of lock, what it would do would be apply out of the inverter in that IC, section C I think it is, it would apply a voltage to the transistor, to a transistor, which would then basically short the base of the supply transistor to this, thereby turning it off, and the voltage to the relay would then go away. So when you keyed the microphone, the radio wouldn't key. So I just need to basically bypass all that, because we're not using any of that anymore, and just supply the voltage directly to this. And then what keys the relay will stay the same. That's the microphone. So when you key the mic, the 6 volts goes, basically comes through the relay, goes to the microphone jack, and all you're doing is supplying the ground for the relay and to switch it into transmit. So other than that, like I say, I need to do add on a little bit of power supply circuitry to run that VFO module over there and the Nomad amplifier buffer board. But otherwise, yeah, the hard work's done, gutting out everything. Well, no, not hard work's not all done, because like I said, I still have to enlarge this hole here. But, that abomination of a PLL has been removed, and the radio's, transmitter's a few pounds lighter now, because that is a hell of a lot of crap. So, I guess the next time you see this, it should probably be together, and hopefully we'll be transmitting. Well, I wasn't going to show it until I got basically done, but I figured out what the heck. So there's my enlarged hole. And I'll tell you what, I got really, really lucky. If you notice, all the knobs and everything are still on the radio. I didn't have to pull the faceplate out and do it on a milling machine. I don't know why I thought about it, but luckily the light bulb in the head was working today. And I looked at that hole size, not so much the width, but from top to bottom, and I thought, damn, that looks just like the size that I punch out whenever I install IEC power connector. So, if you're familiar with the modern power cords, to reach up here and grab one, this style, okay, the sockets that these use, I have a punch to punch out those rectangular holes when I'm installing those, so I don't have to, tear radios apart. All I need to do is drill a hole, basically usually wherever the existing power cord hole is, maybe enlarge it a little bit, and then I use this. This is a Greenlee knockout punch. And I got really, really lucky. This punch size is the exact same height from top to bottom as the hole that was originally in here. So, and I didn't even need a wrench to turn this thing, because this is aluminum. Now, of course, I'm only nibbling it out on the side. That's basically what I use that punch as a nibbling tool. But here's the 4 pieces that I punched out. So I was literally able to just hold that in there, grab the big nut on the back, and because it's aluminum and it's, it's fairly thin, I literally was just able to, muscle it with my bare hand and punch out these 4 little pieces. So that's how I actually enlarge the hole. And like I said, it makes it so much easier. Nice smooth hole, no rough edges. And it also, like I say, saved me from having to remove the faceplate off of the radio, so it never had to leave my bench. So if you ever do one of these, someone happens to feel, inclined to take this project on themselves, just a really, really fast way to enlarge that hole is if you happen to have one of these Greenlee punches. Like I say, this one, it wasn't specifically made for those outlet sockets, but I found it's the exact right size. And it's a Greenlee, crap, where the hell's the numbers? There it is. It's a 3/4 by 1.14 inch punch. So it's, this is a 3/4 inch hole, and like I say, I got lucky. This just happens to be 3/4 inches wide, and I was just able to go in there and take it out in 2 little chunks on each side, and there's my hole, the exact size I needed. So there you go. There's just how I enlarge the hole. Okay, you can see it's on and receiving. Oh my God, there is something wrong with this receiver. It's one of those, you just want to pick it up and throw it out the window. It doesn't matter what you touch inside this thing. The volume comes in, the volume goes out. Now I think at some point in time this thing took a hit on the front in shipping, because the backs of several of the controls have a little dent facing outward, like the inside of the back of the cans got pushed out a little bit. It's either the tone or the volume control, one of these things. And it doesn't matter what you touch. It could be a tube, push down on the board, play with the volume control. That's what's annoying is you can touch anything. Just flex the radio, just slightly touch the tone, slightly touch the volume, touch any of all the tubes. You just barely touch anything. It comes in, it goes out. Ah! So that's going to be the next thing. But we're not worried about that. We're worried about the transmitter and the modification. So as you can see, we now have the VFO installed. It's on, and it does work. Don't pay attention to the little RX. I've got to ground the switching leg out for transmit. But so what we wanted to do was replace, let me turn around and grab it, all of this shit with something a little bit more modern, less clunky, and one hell of a lot more reliable. And even if it does break, a hell of a lot easier to find parts for and easier to fix. This thing had been highly modified. For starters, somebody had Swiss cheesed it. I mean, really, guys, it's an RF shield. What do you think all those holes are going to do for the shielding efficiency of this thing? Yeah, it's not anymore. It's now, it's a perforated shield. But, there were parts bodged all over this board. There's circuit traces cut on this one. It's just, man, and they're unreliable. No matter what you do to modifying it, because this was, modified for extra channels, no matter what you do to it, it's still going to be an unreliable, clunky piece of junk. It was a poor, I wouldn't even want to call it a circuit. It was just a poor piece of junk from the start. And as I've said, it was so bad they had to put a reset position on it. So now these 2 controls are completely useless now. They're not even hooked up anymore, because the wires off of both of these switches went to all those boards you just saw, so they're not needed anymore. They're just, they're nice gold knobs to look at. That's about it. Now this knob is now the tuning control. So you can see as I change it, and I'm not sure how bright that display is there. You can probably see it there. So you can see, and you can change which digit you change. So you can change this thing down to 1 Hertz resolution. Or tens. And what I'm doing is you push in on the knob and turn it, and you'll see a little cursor scroll across the bottom. So if I push that in, you can see that cursor move. And that's the digit that you'll be changing then when you move that cursor. So, it's been installed, and it works. So all of that crap you just saw was replaced by the little DDS VFO module right there. And I think in the previous video clip I actually showed you the module, how I had it put together with the amplifier buffer board mounted to it. Yeah, I was having a brain fart moment when I mounted that thing on there. I was thinking the display was the other way around. It was upside down. So the board was sticking up above this top flange. So I had to basically I just flipped it around, and it's now mounted. You'll see there's actually a screw back in this hole. This was the screw hole that was used to mount the original module that was in here. So I have a standoff that goes straight down into another standoff that goes back into this amplifier buffer board. And that standoff just has a threaded hole running through it down this direction. So it's just, but it's solid. You can see the whole front faceplate of the radio flexes when I move that. So yeah, this thing is in there. It ain't going nowhere. The radio is definitely a lot lighter now because we removed all of that stuff that was in there. And you can see there's a big gaping hole now in here. You'll never see that. It's on the inside of the radio. And if nothing else, that's actually a good thing, because now any components that are hot on the bottom have an easy way for the heat to vent out up through this huge hole now and escape the top cover. So if nothing else, this will have greatly improved airflow inside of the transmitter. And airflow is always a good thing in anything tube type. Let's see. Now, I've had to remove, of course, disconnect all kinds of wires, stuff, because where that module was wired in, it was not needed anymore. The original DC power source wire, it comes in through the cable, because the power supply is actually over there in the receiver. One of those lines, the DC voltage that was supplied to the regulators that used to be on the PLL module that was right here, all of that went away, and I needed a DC source for this display. So what I did was I actually took that DC source, ran it to this regulator to step it down just a little bit. So this is a normal 3-leg voltage regulator. If you notice, it only has 2 terminals on it. I cut off the middle lead because I don't need it. That's the ground lead. And the tabs on these are ground also. So I just have it with a little bit of heatsink compound down to the steel chassis, and then there is a screw and a nut and a star washer on either side. So it's just picking up its ground through the tab. So there's just an in and an out. So, the power comes in from that original DC feed in this lead and then goes out this lead over to the DDS module. Now the buffer board, the amplifier buffer board, that's designed to be run off of the AC filament voltage, so 6.3 volts AC. So that is this little wire right here, okay? That just runs straight down off of that board, straight down to the chassis and ties into the filament, because there's actually a hole right there where a wire comes up through. A lot of stuff interconnects right here for all the filaments. So I was able to just push that wire straight down through an existing hole and tie into the 6.3 volts AC to supply the voltage for the buffer board. So it works. Get the camera swung back around here. I will reach here and grab a microphone. And actually, let me swing the camera out of the way. I got to put it in dummy load. I want to be transmitting on air. Okay, we're in AM. So if you look over there at the scope, you can see me talking into the microphone. And we can flip the meter down here for modulation. You can see we have modulation. And if I switch into, the sideband, you can see we have sideband transmit. Now, I have not done anything for as far as alignment goes yet, so I still need to align it. Get the mic unplugged here so it's not sticking out, jabbing me in the stomach. I still need to do the alignment. Now, I did just a really quick to get this thing working, because when I first installed this, I first powered it up, I keyed the microphone, I had, I don't know, a half watt or a watt. Power was like, holy shit low, and I'm thinking, oh crap, not enough drive. I was like, man, what the hell is going on here? I quickly found the plate tuning on the back of this was way out of whack. Spun that around, power came back, and I just did a really quick, kind of by just using the meter on the front of the radio, bring the power up, a little bit of alignment on the final circuit. So everything appears to be working just fine. So now basically I just need to do an alignment on it, and it'll be done. So it does work. Now, the only thing I am personally not happy with is that look right there. The black, yeah, I don't know if there's much that we'd be able to do about that, because to match this brown with a piece of plastic, that's going to, I don't know if that's possible. But what I'm not really that happy with myself is you see how the low limit and the high limit just slightly sticks out the side. I think I had said that in the previous part of this, that it was going to, this bezel or this window was not going to cover everything right here. Now, I contacted the company that I bought these off of. I asked them, I said, can you make larger ones? Or, do you make them, basically, do you make them, or do you have somebody else that makes them and you just resell it? No, we're just resellers. But they were kind enough to give me the information for the company that makes these. Now, I need to contact them. Now, I know these are die cut, and that's he also said that, the guy I got these from said that. They're die cut, and the initial setup cost on it is really frigging expensive, and I understand that. It's manufacturing, you have to cut it, the tooling that actually punches that out, because it's die cut, so there's machining involved. They're going to have to pay either they do it in-house or pay a machine shop to make their punch-out dies. But this is basically a two-piece window here. You have the first thing they're going to do is punch out this inner rectangle into the black substrate. Then they apply this clear window, because there's actually a window. When I'm touching that, I'm not actually touching the display. There's a clear window in between the display and my finger right now. And it actually has a piece of that's still on there, a piece of protective plastic. You can see me folding it back there. I'm just leaving that on there so the window does not get scratched up. But like I say, and then once that clear is applied, then they do a second punch out, and then that punches out the outer diameter. Now, what I would like to see is I want to get a hold of this company. For starters, can I get it in brown? Anything would be, type of brown would be better than the black. It wouldn't stick out so much, like a sore thumb. But if they could make it wider without having to charge me a exorbitant tooling fee. Now, I'm not going to blame them for whatever fee they charge for setup. It's rightfully so. Like I say, there's actually a lot of manufacturing goes into making tooling and setting up for special stuff. You often hear about how much the coffee pot costs, or hammers and whatnot that NASA uses. Well, that shit costs several $1,000s. You try and make a drip coffee maker work in zero gravity. Yeah, coffee doesn't drip if there's no gravity to pull the water down. So, same thing. That's why that shit costs so much. Same thing with, now granted, this doesn't operate in space, but same principle. There's a lot of one-off stuff. It costs money to get set up. Now, if they could just come up with something brown, anywhere close in color, because these windows here are not an exact match for this color, but if we can get something a little bit closer in color to the brown, they could punch out that center rectangular hole, apply their clear top to it, the clear window portion of it, and just let it at that, and just sell me big chunks of it. And then I could cut out, to avoid that large setup fee, I could punch out or cut the final height and width of it, maybe. Another option, and this is going to be expensive. Like I said, I called them earlier, and they were out for lunch, so I have to call back. I got the operators. Yeah, I'm sorry, but I looked at the clock. Yeah, hell, it's 12:05. Of course, I would call at lunch. Why not? But the other thing I could see is, how about replacing this whole thing? So get them to make a window or an overlay that covers this entire center section in brown. That's the only thing where I'm going to want. If I'm going to do that, it's definitely going to have to be a very close matching brown. But come up with an overlay. By doing that, we can now remove this control. Because remember, these two controls are not connected anymore. They serve no purpose. So if I could get an entire overlay made up, then we could get rid of the scan rate, do away with this high-low here, and just put the word like channel above it. And then we wouldn't have to worry about any of this shit. It would just all be one piece. I'd punch the hole out for this display, put the overlay on it, problem done. And actually, they could. I wouldn't even worry about that. I could punch out the hole for the control. Main thing I'm worried about is getting making that perfectly rectangular hole. That's the whole key. You need a punch press, to do that, and the dies to do it. So, there's just an idea. Like I say, it works. I mean, you have to understand before we had a radio that did not work and the PLL and synthesizer module had been butchered, and trying to reverse engineer all that crap that was done to it, all the parts that were added, all the circuit traces that were cut, yeah, it's just, you'd have more time and money in trying to figure out what the hell somebody else did to that. And then once you figured out what they did, you still have to troubleshoot what the hell ever the problem is. Because there was a problem in the address lines there somewhere. But like I say, hell, it was almost as cheap to install this damn thing for this guy. So, and now it's infinitely tunable. Like I say, he's not stuck with channel, he doesn't just go to channel 18 and go, okay, well now I got to clarify or something. No, your tuning control, you just push in, turn to the right. You can tune your frequency if you need to go up. Maybe somebody tells you, especially when you're on sideband, if you're receiving them fine and you're transmitting and they tell you, you sound like you're off a little bit. Maybe their radio's not aligned properly or something. Bring up your transmit frequency like 50 hertz. So it's just a matter of going in here, move the cursor over to the 10s, bump it up, or let's say down 50 hertz, bam, there you go. And that leaves you, by having both of these separate, you do have, just like it was originally, you have separate transmit and receive. But now since this is adjustable, you have separate, basically infinitely tunable receive and infinitely tunable transmit. So you have, set up more like a ham radio. So there you go. There's what she looks like. The only thing I need to do now is, like I say, apply a ground so this says TX instead of RX. Now, I'm not going to do it right now because the more I look at it, I'm really not sure. I've really got to put some thought into it. It's not going to be right now. I've just got shit piling up here. But my thought is eliminate that in the receiver. Okay? The only thing we would have then would be the VFO. Because we have a crystal position here too. Well, I could plumb in the... That's the thing. I'm going to need a switching circuit to switch the output of the VFO between receive and transmit. So there's going to need to be a lot of additional circuitry added. But I need to play with this. I need to pull one of mine out because I have several of these myself. I need to pull one of mine out, basically install this, get it to this point right here where it works off the VFO. And then what I need to do is try, or actually I just need to take my receiver. Hell, I don't even really need the transmitter. I could just use the VFO outside of the radio like I initially did when I first tested it on this. But see if I can get this, make it work properly with the receiver. If I can get it to work properly with the receiver, it looks like it, like I said, I need to play with this because that's the thing. This crystal, the CB1, CB2 crystal position switch, there's sections here, there's this section, and there's this section. So we've got multiple points here, what we're feeding off of. And you see that ties over. Okay, that's, yeah. Anything we have these crystals here, because here, like I say, here's the crystal position. So you could add a crystal, and I might be able to just break this line right here where it comes up, and feed that in. I just need to, like I say, that's also. I have to check with these frequencies on this half here, because this switches between CB1 and CB2 to this crystal and the crystal position. So I need to do some playing around. Like I say, there's going to be additional circuitry is going to need to be made to do the switching for the VFO. So so when it's in receive, there's no frequency being generated inside, or, well, it's going to be inside of here, but it's not going to be being sent to the transmitter board. It'll be diverted over to the receiver, and then when you key the microphone, it'll divert the output of the VFO, or actually that buffer amplifier board. It'll divert that signal back into the transmitter. But yeah, I'm going to have to play with that. So that'll be at a later date. But the main goal of this was to get a replacement for the junk PLL system in this thing, and it works. And it honestly wasn't that hard. There was time laying out the holes. I mean, don't get me wrong. There's well over a day in just doing this right here, especially first time around. Lay out, you got to figure out, oh God, what all do I got? All this wire and crap you got to cut out of there. What do I need to bypass? What do I need? Like the relay, you've got to rewire the relay because it's no longer being supplied its voltage anymore. A lot of little things to work out. But now that that's done, in future, it would be a lot faster to do it. So I'm going to do some investigation on window material and whatnot. If I just get a little bit wider one, I'd be happy with that. If I can get it in brown, all the better. If it's not too ungodly expensive to get this entire section made up, hey, that would be even better yet. If you could get an overlay that perfectly matches the outside of there, maybe just a little bit more, to just stick on here, cover up that one hole, and then have a new one-piece overlay right there. That would be great. So there you go. Took a non-working Mark IV transmitter or PLL synthesizer circuit and have installed a working modern DDS VFO.